5.8, salts. It's more about salts and importance introduction. We understand the most common salt is sodium chloride, and it is mined from underground in many parts of the world. Around the world, the two biggest mines are actually in Poland and Pakistan. These are one of the biggest mines around the world. But we do get a lot of salt from the seawater. Apart from that, there are many other salts which are given at this bottom table, table 5.10 on the same page. And when it comes to this table, I usually ask my students to memorize the whole thing. Actually, most of the salts are what we are going to frequently discuss in the book, so you would get to know them. For example, we started off with discussing ammonium chloride back from the sublimation examples. We understand if it's a chloride salt, it has been made from hydrochloric acid, it has white crystals, it's used in fertilizers and dry-cell batteries. Ammonium nitrate made from nitric acid is used in fertilizers and explosives. Ammonium sulfate from sulfuric acid is used in fertilizers. Remember, all ammonium salts are used for fertilizers, so it's a pretty good way to remember all of them at the same time. Next up is calcium carbonate. We have discussed it a lot. Marble, limestone, chalk are different forms of it. It comes from carbonic acid. We actually carve out decorative stones out of it. We make lime, cement, or extraction of iron also uses it. Calcium sulfate, gypsum, or plaster of Paris, which is most commonly used for plaster casts around the world for fractured bones. Apart from that, it's used for wall plasters, and it comes from sulfuric acid. Sodium carbonate, which is commonly known as washing soda, and is actually a part of detergents as well, it comes from carbonic acid, is white crystals of powder, is used in cleaning purposes, water softening, and also making glass. Magnesium sulfate, Epsom salts, is commonly known. The parent acid is sulfuric acid, white crystals, and these are health salts. They're actually laxatives and commonly used for the removal of constipation. Copper 2 sulfate, which comes from sulfuric acid, has blue crystals. Remember, copper is the only transition element in the whole list. Hence, as soon as we touch the transition elements, there you go, you have colored salts. That's why the entire list is white except this one. It's used as a fungicide and something that is used to remove fungus. Calcium phosphate is the last one, comes from phosphoric acid and is used to make fertilizers. So these salts are pretty easy. If you can't cram them in one go, don't worry. We're going to discuss them, most of them at least, frequently and upcoming portions of the book, and you would memorize most of them. Sea salt is not just sodium chloride, it also contains magnesium chloride, calcium sulfate, potassium bromide, and other salts. This is another important part from this page. However, moving on, talking about salts, as table salt is the most important one, let's talk about its importances by numbering them. It has actually a number of functions. One, it is used for muscle contraction. Two, conduction of nerve impulses in the nervous system actually is enabled by this. Three, it regulates osmosis, the passage of solvent molecules through membranes. So that's the third. And fourth, it is converted into hydrochloric acid that aids digestion in the stomach. So that is number 4. These are 4 uses. When we sweat, we lose both water and sodium chloride. Loss of too much salt during sports and exercise can give us muscle cramps. There are isotonic drinks, the drinks that are designed to replace the loss of water and somewhat mineral salts as well. That's why we drink mineral water. Apart from isotonic drinks, there is stored energy and balance of mineral lines in the body. Now, we can take salts out of mining, but there are a number of salts that are made in laboratory too. When we are working out the method of preparation of a salt, there are 2 important things that we need to know. The solubility or insolubility of a salt in water, and does it contain water crystallization? Let's talk about both points one by one. Starting with solubility or insolubility of salts. When it comes to that, IGCSE has a very good table to give you a pretty good idea of what you need to remember in terms of soluble and insoluble salts. Now this is table 5.11 and this study tip. Both are the same thing. Study tip actually summarizes this entire table. But what I ask most of my students is not to go with the study tip. Instead, this table is pretty good. Otherwise, you can take hints from the study tip to memorize this table better. That can also work well. Let's go with the table. First of all, the table is drawn in such an easy way that on top of the top 5 of these, you would find that all of them are soluble. All sodium salts, potassium salts, ammonium, nitrates, and ethanoates are soluble. Pretty easy, right? Chlorides, most of them are soluble, just 2 are not soluble, that is silver chloride. Actually, I would really love to add silver 1 chloride over here, and lead 2 chloride, the formula for which is PbCl2. Sulfates, most are soluble except barium sulfate, which is BsO4, lead 2 sulfate, which is PbSO4, and calcium sulfate, which is CaSO4. You must be thinking why we are writing lead 2 every time, although it's a part of group 4 and it's not a transition element, but still that exists in different oxidation states. That's why we need to do that. Carbonates, most are insoluble. Only 3 are soluble, which is sodium carbonate, Na2CO3, potassium carbonate, K2CO3, and ammonium carbonate, the formula for which is NH4 twice CO3. So these are the only ones that are soluble. Why? Because sodium, potassium, and ammonium salts are soluble. Most are insoluble in this case. So it's pretty easy to remember. Remember, 4 of them were straight away soluble. Chlorides were all soluble except 2, sulfates except 3, and carbonates except 3. So that's it for the solubility of salts. If you memorize the entire table, it's pretty easy to judge these salts. Sometimes students tend to ask that if there are so many salts around the world, if they use some other salts, yeah, we have a list of most of the soluble or insoluble salts, so we're going to work with that. Apart from it, if any salts come as a part of exams, you would find IGCSE to be very fair, and they're going to there and then tell you in the question whether it's soluble or insoluble. If they don't tell you stuff like that, and they ask you a question, remember there would always be a hint in the question. For example, I've seen them using a completely out of the blue salt, something that which isn't even a part of this table, and then not telling the students whether it was soluble and insoluble, but giving them a hint that that salt was separated with the help of filtration on top of filter paper as a residue. Now, this is a pretty straightforward hint that the salt is insoluble in water. This big of a hint, and even if it's not from the table, and as I've already said, they're very fair when it comes to that. So don't worry, if any salt is not a part of this table, remember IGCSE is very fair about it. They're going to tell you or give you a hint in the question. So keep your eyes open, keep a good grasp of the book, and you would easily be able to get through this part. Moving on, the second part was about water crystallization. Let's first define it. There are crystals of some salts which contain water crystallization. This water gives the crystal their shape. In some cases, it also gives them their color. Copper sulfate, for instance. We call them hydrated salts. Actually, water is a part of the salt. And if that happens, what happens when we heat them is that they lose their water crystallization, which is driven off as steam. As soon as the structure loses it, it also loses its color. It becomes a powder, it loses its shape, and sometimes, most of the time, they are going to dehydrate to form a white powder. Sometimes they can also be converted into a different color. There is a list of a few salts that are part of IGCSE Tables 5.12 table. I appreciate the students memorizing it. Some of them are colored, some of them are already white. This would give you a pretty good idea that how many number of molecules can be attached to it. And you would see there are different number of molecules over here. For example, copper 2 sulfate is 5, cobalt 2 chloride is 6, iron 2 sulfate is 6, magnesium sulfate is 7, sodium carbonate is 10, calcium carbonate is 2. Now, their colors are pink, green, blue, pink, and green in case of copper, cobalt, and iron. And I think it's pretty understandable as all three of them are transition elements. The rest are simple metals. That's why all the salts are white. Now, coming to this reaction, this is known as a dehydration reaction. The water has been driven off as steam, and blue hydrated copper 2 sulfate crystals are converted into white anhydrous copper 2 sulfate crystals. They have lost water of crystallization. We call them anhydrous. So this one's hydrated and this one's anhydrous. Now, this reaction is known as a dehydration reaction, and it's a separate kind of reaction other than what we studied back in chapter 4 in types of reactions. Remember, this reaction can be reversed if water is added to the white powder. It can be converted into blue again. Remember, for this, we heated it up, and when we're going to turn it from white to blue again, heat would be given out, which is going to be an extremely exothermic reaction. This can also be used as a test for presence of water. If you have a colorless liquid and you don't know whether it's water or not, pour a drop of it on top of white anhydrous copper 2 sulfate, it would instantly turn to blue. The two tests, dehydration and hydration, are already a part of this book. The CD that comes with this book also contains the videos. The videos are also available on YouTube. Simply search for it, and you will find the dehydration or hydration reactions of copper 2 sulfate salt. That's about it for 5.8.